Today's lesson is going to explore asymptotes. Now, I know we've seen asymptotes before, but when they relate to rational functions, we have to be able to identify all the different types of asymptotes that we will see, not just the horizontal ones which we might have seen before, or sorry, the vertical ones that we might have seen before, but new horizontal ones that we haven't seen before in these types of functions. And then later on, we'll actually get to diagonal asymptotes. So first, let's just remind ourselves that a rational function can be expressed as f at x equals p at x over q at x. So you have a possible polynomial on the top divided by a possible polynomial on the bottom. And because it's the division, that's where the rational function comes in. The disclaimer you'll notice here is, of course, the bottom polynomial cannot equal 0, because if it did, you'd be dividing by 0, which is not allowed. We'll be using that to help us identify some of the different functions. Now you'll notice that you see a graphing calculator up on the screen. You'll need a graphing calculator to do this exploration as we go along, and we might need to pause the video a number of times for you to have some time to actually look at the graphs that I'm asking you to look at and see if you can discover on your own before I give away the secret. So feel free to pause the video as you're going along. So here's how we're going to do it first. So what I want you to do is make sure the reset program is run. So program, reset, enter. And then I want you to put these three functions into the graphing calculator on 3 different lines. Now be careful of how you write this in. So for the first one, it's 1 over, so 1 divided by, and then make sure you put the bottom in brackets because you're divided by the whole x plus 3. So it'll look like this, 1 over x plus 3. If you just put 1 divided by x and not have a bracket, plus 3, that plus 3 won't be part of the bottom of the function. So I'll give you a second to enter these all in. And on the third one, you'll notice that I have an x plus 2, so it has to be in brackets, as is the one on the bottom. Oops. So those are the 3 functions. Now this is where I'll let you pause and you can go off and explore what these functions look like and what do you notice about them. So feel free to pause at this time. Okay, so you've had a chance to look at it, and maybe you've noticed similarities between the 3 of them. I'm going to graph them. See that that one comes along. There's a new one that looks like that. And hopefully you'll notice that all of them have vertical asymptotes at -3. So if you look right here, right here, you'll see there is a vertical asymptote right at -3. Now this really shouldn't be a surprise, because if you look at the bottom of each of these functions, if you sub in -3 here, you'll get a 0. If you put in -3 here, you'll get a 0. And if you put in -3 here, you'll get a 0. So all of them have a vertical asymptote at -3. The second one actually has 2 vertical asymptotes, and you can probably see that there's also one at +3 for that one. There's your vertical asymptote at -3, and this one has another one at +3. But what, of course, is what I want you to notice is that all of them have vertical asymptotes at -3. So our first conclusion then is vertical asymptotes pop up when we do this. So unlike polynomials, rational functions have breaks where x is not defined, and it occurs when the denominator is 0. So if I give you a rational function, the first thing I'm going to ask you to do is find vertical asymptotes. You can find when the denominator is equal to 0 and find the x values to do that.